Firstly, I'd like to welcome everybody to this Petrosys webinar on effectively utilising third-party data in Petrosys. My name is Andrew Dunn. I'm a support geoscientist out of our regional European office here in Glasgow in Scotland. Just a couple of housekeeping points of order. Firstly, this webinar will be recorded. If anybody wishes to ask questions, the microphones will all be muted during the webinar, but I'll invite questions from the audience at the end. There's a couple of other ways you can ask questions. You can enter questions into the GoToWebinar chat bar at the top right-hand corner of your screen. You can email or call us directly. I'll provide email addresses and a phone number at the end of the webinar. Or at the end of the webinar, there's also a feedback form which allows you to capture any questions you might have. I'll respond to these as soon as I can after the webinar. So if we get started, firstly we'll just have a look at the agenda. We're going to have a short PowerPoint presentation which runs through how Petrosys utilises third-party data, give you a brief introduction to it. We'll then run through a demonstration which will follow a hypothetical workflow situation from regional mapping through to 2D and 3D subsurface investigation. And then at the end I'll unmute people's microphones and invite audiences from the questions from the audience should anybody have any. So we get started with our PowerPoint here. So how does Petrosys utilise third-party data? So for those of you who might not have used Petrosys before, it works with your existing technologies to build surfaces for structural models and geomodels, produce high-quality working and final presentation maps, as well as 3D visualization, all of which is facilitated by direct connectivity to core geoscience applications and databases. So Petrosys models the following data types: wells, seismic, grids, faults, culture, spatial and image information. It does so directly from established interpretation solutions such as Landmarks, Schlumberger, Paradigm and IHS Kingdom, as well as from in-house gold standard master data stores such as OpenWorks Finder, EPOS and PPDM. In addition to this, it leverages the use of the value of spatial, cultural and image information stored in directories and applications such as Esri's ArcSD, Esri File Geodatabases and Oracle Spatial, to name but a few. This slide here just gives you a more comprehensive list of all of the applications and databases Petrosys connects with or talks to. If anybody has any particular questions regarding a particular data source, application or database, then I'm happy to discuss these at the end with you. So now we're going to skip into our demonstration. Again, I'd just like to reiterate this follows a hypothetical workflow situation, and for the time allotted to this webinar, I will have to gloss over a lot of the processes that you spend many days, weeks and months and even years working on. So please just bear that in mind. So in the initial reconnaissance stages of exploration, we build regional maps to help us assess the geological and commercial potential of an area. At this stage, much of the information we might receive comes from a variety of different sources. So for example, vendors, government agencies, potential joint venture partners and our own regional modelling. The challenge we face is how to combine this data in a useful manner so as to aid us in the decision-making process. So if we start from the point of view of cultural information, I've got a couple of layers here which are being displayed directly from our Oracle Spatial database. This particular layer represents the exploration maturity of the Norwegian continental shelf. And although this data is external to Petrosys, we have full control over how it's displayed and what we display. So for example, filtering for attributes, things like this. Just to give you an idea of some of the other data sources available, I'll show some of these in a moment, but we've got things like ArcSD, shapefiles, ZGF files, MapInfo files, Esri personal and file geodatabases, to name a few. If I go ahead and display these layers, you'll see the other layer actually represents the Norwegian coastline as well, so helps to give our map a bit of spatial context. One of the other common data types you use during exploration is license block information. So for example here we're adding a layer to our map which is provided by a government agency through a web map server or service. So we've got a direct web access to, in this case, this layer represents APA open areas, so license blocks that are available for exploration, and we're going to add this to our map in a moment. But we've also got some more generic license block information for the Norwegian sector, which was provided to us by a data vendor such as IHS or Petroview in the form of a Esri file geodatabase, which is a common format to receive such data in from vendors. And again, although it's external to Petrosys, it's in an Esri format. We have full control over how it's displayed and what we display. So if I just turn on these two layers, you'll see we've added some more context to our map. We're building up an overview of the area using a range of different culture types. I can also add this existing pipeline infrastructure information, which was given to us directly in Esri shapefile format. So as well as cultural information, it's important to us to be able to see what seismic and well data is available to us in this area. In this case, we're using our own PPDM master data store, but we could easily be accessing data from other databases you may be using as master data stores such as Finder and OpenWorks, as well as project data stores such as Petrel, SeisWorks, or IHS Kingdom, which we still have referred to as SMT, but that will be updated shortly. And again, even though this data is external to Petrosys, we have full control over the style and what information we display. Let's go ahead and turn this on. Even though I'm displaying 2D seismic here, we could be doing the same thing for 3D bin grid outlines. And for well data, again, we're using a PPDM, our own PPDM database, but we could be accessing data from things like Geoframe, Geographics, OpenWorks, Petrel, and IHS Kingdom. And again, we've got full control over how it's displayed, so what well symbols, the red from the current symbols that are stored in that database, and we can also display paths, formation tops, etc. So just to recap what we've done so far, we've built a regional map which includes all of the cultural well and seismic data available to us. Next we need to interrogate this data so we can see what's available to us going forward. So from our workflow perspective, our initial reconnaissances led us to identify a potential area of interest, which is denoted on our map by this pink polygon. If I zoom into this area, just be able to show you how, as I mentioned earlier, Petrosys maps are not static images, and as such we have the ability to interrogate the data that we're displaying. And as all the data that I've shown so far is accessed directly using Petrosys Multi-Connects, we've managed to reduce our data management challenges and overheads as no data needs to be moved, loaded, or coordinate converted, which means we have access to the most up-to-date data instantly, as our multi-connected maps are not static. So as our maps are not static, we can actually interrogate and interact with the data on them. So for example, with culture data, I can just zoom into any of my map area, and I can click on these license block outlines, and I can use this query attributes option to pick any of the attributes that are stored against that data from its source. So for this example, it's an Esri file geodatabase, and I can ask Petrosys to report this to me interactively. So for this example, I've picked block name, operator name, and round name. So if I go and click around the map, you'll see that it reports the relevant attributes I've selected for these for the items that I'm selecting interactively. And this may be useful in our workflow context, so we can see who's currently operating blocks in this area, or we can see who's operating blocks around the areas we may be interested in, so potential joint venture partners. So as well as interrogating culture data, we can build lists and query our seismic and well data that's available from our databases and project data stores. So I just go and look at our seismic lines here. One of the simplest spatial queries we can use is just to add all the lines in our current map area. So once we've done this, you can see, if I just zoom out again, you can see there's 466 lines that fall within our area of interest map here. So we've built this list using a simple area of interest spatial query. As soon as I've got this list available to me, I can right mouse button and I can export it to ASCII, or I can export it to Excel and share this information with whoever I want directly. There's other ways we can query this data or build up lists. For example, using an interactive ad hoc hand-drawn polygon. So I can just digitize a polygon on my map here, and you'll see it appears with a thick red outline. And what I can use my list to select only the seismic lines that fall within that area, and I've asked it to truncate those lines so that it doesn't report any portion of the line that falls outside of my polygon. I just click OK to that. You see we've now got 100 active out of the initial 466. I'm just going to remove the inactive ones, and we can also use a range of other spatial methods or query methods to restrict this data. So we can use things like standard forms that we give you for things like line ID, line name, etc. We can also use wildcards, or we can use user-defined SQL queries, and we can work with our clients to provide customized queries if they wish. So an example of a query might be to show me all the wells that have contain a certain top, or something like that. And once we've created our subset or our list, we can translate this information onto our map by saving it as a selection file. So if I just save this selection file here, I go onto my map, open my 2D layer, and pick my seismic line selection. You see that my map's updated with that information that I've queried here in my list selection. So there we've updated, we've reflected our list, our query on our map canvas. As well as being able to do these more broader reaching queries, we can also interact with the individual items on the map. So much like the culture, if I zoom in, we can click on individual seismic lines and look at things like the line header, or we can query that line directly. For wells, for example, we can look at the individual well header for that well, look at things like coordinates, and we can also look at the things like the formation tops and directional survey information for that well, etc. So by using this live link to the data, we've seen so far how Petrosys can allow us to interrogate and confirm the integrity of map data. A specific client example that we have at the moment is one of our clients is migrating a lot of project seismic data into a master data store, and they use the Petrosys mapping multi-connects to visually query the spatial integrity of that data that's been loaded, because it involves some manual manipulation and loading of data and also coordinate conversion, as all these projects use different coordinate systems. And they can use Petrosys to build up lists, say, to report how many lines fall within a map area, and they can check this against the project, or they can see directly by displaying their master data store that's currently having the data loaded to it and the existing project data on the same map if all the data lines up, and it gives a very effective visual QC. So from our workflow perspective, so far we've compiled and queried all of the regional data available to us from a variety of sources, and at this point we've identified an area which we believe to be prospective and would like to investigate further, and this is denoted by this pink polygon again on our map, this area here. And I'm just going to open a map sheet that covers this area so we can zoom in. So if once we zoom into this area, we'll be able to see that there's a particular block that we're interested in. And this is going to be highlighted in red here. So the next step in our workflow process is to gather some seismic data to allow us to begin investigating the subsurface. So in this case, one of our partners has acquired and interpreted some 2D data over this area that they're going to share with us. Unfortunately for us, their main interpretation tool is IHS Kingdom, whereas we are a Petrel-only shop. So traditionally our geoscientists would have to wait until this data had been exported from Kingdom and loaded into their Petrel projects until they could use it. But by using Petrosys Direct Connects, they can have access to this interpretation as soon as it becomes available. One of the added complications we have is that our Petrel projects and our corporate standard for this area is to map, or and model our data in ED50 UTM zone 31, which is the same as the CRS, the Petrosys map we're using. Unfortunately, the data we have in the Kingdom project is in WGS84 UTM zone 31 north. So again, it would involve some coordinate conversion before loading into our Petrel projects, and there's some inherent uncertainty and data quality assurances or QC that needs to be performed in that data once it's been loaded. The way Petrosys can handle this is that on the fly it will take the data from this data source and coordinate convert it on the fly using our own coordinate conversion routines. And by this I mean we don't rely on any third-party data or third-party software to do this. It's all developed in-house by Petrosys. And combining this with our industry standard EPSG coordinate reference system definitions, we can coordinate convert this data on the fly into our map sheet CRS, allowing us to map from multiple data sources in different CRS in a consistent manner. So as I said before, we've got a Kingdom project here. Again, it could be data coming from something external to our normal interpretation system, so something like SizeWorks or OpenWorks. And you'll notice that SizeWorks and OpenWorks are not, they're traditionally Linux applications or databases, whereas we're, through Petrosys, we can actually access this Linux based data and information in the Windows environment, so you can map and model it alongside your Windows only environment interpretation tools such as Petrel and IHS Kingdom. I'll just go ahead. As I mentioned, this data being external to Petrosys, we still have full control over how we display it and what we display. So for this example, I'm going to display the horizon interpretation for this top ETIV horizon. If I turn these layers on, you'll see that we've now got our 2D navigation from S&T, including an overlay of the interpretation as a ribbon map, and we've also got some faults that we've picked. As I mentioned before, all of the items on a Petrosys map are fully interactive, and our 2D seismic interpretation here is no different. So I can scroll along these lines and you'll see at the bottom it reports the line name, the shot point range, the shot point number, and the interpretation value for that location along with the coordinates. So the next step in our workflow is to model our 2D interpretation we've received from Kingdom, grid this up, and as the Petrosys Direct Connects extend into our surface modeling module, we can do this quite easily. So if I open up this workflow here and expand this first task, you'll see that we've got our Kingdom seismic data as input to this gridding task. If I expand the input data, we can have a closer look at what's available to us. So as I said, we're connected to our Kingdom project and we're gridding up this top ETIV horizon. We could also have additional inputs to the surface modeling job using Linux-based, so cross-platform capabilities there, using Linux-based applications or data stores such as ISX or SizeWorks, along with input data from our Kingdom or Petrel projects. We can also take well data, use well tops directly for our surface modeling, so for example Geoframe, OpenWorks, Petrel, IHS Kingdom, etc. As well as using our well tops for surface modeling, we can use this information to tie existing grids or flex existing grids. So for example, we could create a surface from data held in Petrel, or we could bring a grid in from Petrel and flex this using well tops and OpenWorks, etc. We can also use spatial data directly in the surface modeling process, so things like Oracle Spatial, SD, file geodatabases, etc. So as I mentioned, we can build up a list of inputs. We're not restricted to one data input to a surface modeling job. And again, using the Petrosys CRS capabilities, we're not restricted to one coordinate reference system. So again, we could have input from IHS Kingdom here, we could also have Petrel, OpenWorks, etc. And these could all be in different coordinate reference systems. And at runtime, Petrosys will coordinate convert this data on the fly to allow us to output a grid in a CRS of our choice. So for example, our Kingdom project was in WGS84 UTM 31 North. Our output Petrosys grid is going to be in ED50 UTM zone 31 North. Another important area that the direct connects extend to in surface modeling is the direct use of faults. So for example, I'm using a Petrosys fault file this time, but we could be using faults directly from our Petrel project or our Kingdom project, etc. So I just go ahead and run this task, connect to my Kingdom project. So as that surface modeling task now run, we can go back to our map and QC the output surface. So as useful as it is QC in the grid in 2D, it's expected that we should be able to do it in 3 dimensions also, and we can do this via using the Petrosys 3D viewer. If I can just get that open there. So I'm just going to open up the grid that we've created, and we can QC this in 2D. And although this is a Petrosys grid that we're displaying here in the 3D viewer, the multiple connects extend into the Petrosys 3D viewer. So I just turn off our grid for a moment. We can also display things like well paths and tops from a range of different data sources. So I could be connecting to a Kingdom project and display my paths and tops for specific horizons. But I could also at the same time display, say, a grid from my Petrel project. The depth structure from my Petrel geomodel. And this allows me to do powerful QC of normally disparate data sources. So I could QC this, this grid that I've created in Petrel against tops that are held in a completely different interpretation system or database. So for example, tops in OpenWorks, again highlighting the cross-platform capabilities. If we go back to our original surface, one of the powerful things about the 3D viewer as well is we can drape, we can take 2D maps that are multi-connected and display these and drape these over the surface. So for example, this map that I'm putting over the draping over the surface here contains our original Kingdom 2D navigation and interpretation. It just helps us add context from mapping into the 3D domain into the subsurface. So for the purposes of our workflow, our hypothetical workflow, we can just say that we're happy with our initial 2D time surface we've created, and if we weren't, we could go back to our surface modeling, say we'd reworked our interpretation, and we could just rerun our task that's connecting to Kingdom or whatever third-party data source, and Petrosys will requery this data source for the new data, and our output surface will be built using this alternative interpretation. But as I said, for the purposes of this workflow, we're happy with the surface that we've output, and we want to move on to the next stage. So the next stage is just to depth convert this surface and write it back into Petrel. If I open up this this task, exporting to Petrel, we're taking a Petrosys grid this time and writing it out to Petrel, but we could also be taking a grid directly from ArcSD, GeoFrame, OpenWorks, etc., and writing these into our Petrel project. So Petrosys extends its multi-connects between different applications. It's not just an application to Petrosys to another application. There are areas where we allow direct connections between 2 different applications. And as I mentioned, we're writing this out to Petrel, but we also write grids directly out to OpenWorks and Paradigm. So I just run these 2 processes. And we go into our Petrel project. We can see that we've now got our 2D depth structure available in our Petrel project for any surface modeling, or any structural modeling or geocellular modeling purposes. Let's turn that off. So, in terms of our workflow, our 2D investigation has allowed us to identify an area where we'd like to acquire some high-resolution 3D data, and this is represented by the 3D bin grid I'm going to display here from Petrel. Let's turn off our Kingdom interpretation as well. So in this situation, we've carried out our interpretation in Petrel, but using our Petrosys direct connections, we're able to continue mapping all of our Petrel data from initial interpretation, which I can display here. So this is the initial 2-way time interpretation of the 3D, through to picking of our fault polygons or creation of our fault polygons, through to depth conversion. So here I'm displaying the depth horizon and depth from our geocellular model, eventually to creation of the geocellular model and drilling of our targets, so we can display the wells, etc. here. So by continuing to map within Petrosys using direct connects, we're able to produce high quality presentation maps which surpass the capabilities of our interpretation systems. And we also maintain our workflow continuity and capture all the ideas that led us from our regional mapping phase down to our geological modelling and eventual drilling of our target. So from our workflow perspective, we can now bring things a bit more full circle, and we can merge our original 2D depth structure grid in with the 3D grid we created in Petrel. We just run these last tasks here. If I open up our Petrel project again, here you can see we've now got the 2D and 3D grids merged and available to us in our Petrel project. We can actually take this a step further and make this data available, make the data output from our surface modelling available to our preferred GIS solution. So in this case, ArcGIS is our preferred solution. So I can take our Petrosys grid, contours and faults that we created, and add these to our ArcMap display. And these are all Arc native objects, so we can utilize these in ArcMap and we can interrogate them. So for example, if I use the Identify tool, I can click on our grid. It's not just a picture. We have Z values as well, so you can actually utilize this data in ArcGIS properly. So I return to our presentation. So just to kind of summarize, how can Petrosys Direct Connects help with my workflows, or your workflows in this case? So from a mapping perspective, you can access all of your cultural and geoscience data in one place. There really is a pretty comprehensive list of data sources for cultural, seismic and well data. And data is accessed directly from these sources. It's not loaded into Petrosys or copied, and this helps to reduce data management challenges and overheads, as there's no loading of data or populating project data stores, etc. And we can map multiple data sources in different coordinate reference systems. So it allows you to output maps using a corporate standard, or taking data from interpretation systems and mapping it in a different CRS, which means that you don't have to then coordinate convert that data. It can remain in the original data source at source, reducing any potential conversion errors, data loading errors, etc. From a surface modeling point of view, surface models are built using all the data you have available to you. So again, this includes multiple data sources using different coordinate reference systems to produce one surface. And you can access your interpretation as soon as it's available, regardless of source. So say, for example, you go to a data room, and you can access interpretation directly from a wide range of sources and surface model it in Petrosys or QC it, etc. And the outputs from your surface modelling can be shared directly with Petrel, OpenWorks Paradigm and your Esri environments. And also 3D visualization, you can combine information from a range of disparate data sources across Linux and Windows in one easy-to-use 3D view. So that brings us to the end of our webinar. I hope that it's informed you about the possibilities of working with Petrosys to improve your workflows. The video of the webinar will be uploaded to our YouTube channel and is also available for download or viewing from our webpage. If you have any questions, you can contact me at the email addresses shown below on our screen.